We're gonna start pre-wiring our van. Ooh. And what are we doing with our pre-wiring?
Yeah, well, there's a lot of wires to run. There's like even things that you don't typically think about, like your switches, or if you have three-way switches, your control panel, right? Like all the buttons that you press to control various things. So yeah, we're gonna start by just wiring up some of our AC devices and then go from there.
Nice, let's do it. Let's do it.
Yeah, let's do it.
Time to crunch.
Time to crunch. So there's a couple places that we have to cross the van. So that would be kind of in this area. And we're gonna use this C-pillar as kind of the main raceway to go up, across the ceiling, and then down. So this is where we'll have like our fridges, our water heater, control
fridges.
Panel.
Oh man,
you gotta be,
luxury.
You gotta be stacked.
How many are we?
At least 2.
At least 2. All right, you heard that here first. 2 fridges.
Yeah. So yeah, right now we've got the fishing line through here, down the C-pillar. We're probably just gonna. This is our 12-3 triplex for our AC. So we're just gonna tape it to the fishing line and then start reeling it up.
And catch some fish.
Catch a big one.
We're learning how to do things.
So yeah, we got the AC across. That went pretty smoothly because there's no wires really there yet. You got your muscle face on.
Down there somewhere. Can you see it?
Not yet. Oh, there it is. Ta-da!
Can you just leave this here?
Yeah, if it doesn't fall.
Okay, well if I get conked out, help me.
Conked out. First point and laugh.
Hey! That's just mean.
What's that smirk?
I'm like, am I doing this right?
You're like, I think this is tape.
I don't know if I like this better or actual fishing better.
Yeah.
Yeah, this is a workout.
Is it? We're getting close. Oh.
Oh god. Alright.
Nice. We gotta unwind some more.
Unwind some more. I need like 5 hands to do this. Props to anyone who does this by themselves. Nice.
Okay. So now we gotta take off the tape.
Yeah.
And then we'll feed it through this side.
Yep. So we've been really into Monster lately.
We get them on a discount. Just looking for deals. Well, these are sugar-free. It's basically healthy.
Okay. We just got a watermelon flavor in the most recent batch, and I added mint to it. I don't know if you can see. So it tastes like a nice little...
It's refreshing.
Fun refresher. Yeah. Pretty good.
Woo!
Highly recommend.
Tastes like energy.
Alright, so it's the next day and we got a little bit more wiring done, but we have to call it a day soon. So we'll walk you through what we've done.
Yeah, so we used pretty much 3 different types of wires. So we used 12 gauge duplex, 12 gauge triplex, and 14 gauge duplex. So here's some of it. Here's our main lighting. So these are our main circuits that we've wired so far. There's still going to be additional stuff for like each individual light that branches off of this circuit. Main lights. What else do we got here? We got some overhead stuff. So this will come from the battery over to this side where we have our bump out lights for under here. We have some more stuff down here. Fridge, which is DC. We also have an AC plug here for our water heater. This is our triplex. And then we have just a pre-run of our 3-way switch, which we'll need to connect between one switch to the other switch so that they both control the same circuit of lights. And then on this side, yeah, you have some of the stuff that I just mentioned over there. And then we also have, what is this? 3-way switch, fridge, water heater.
Lots of nice labels
Yeah.
to make sure that we know what each thing is.
Yeah, for sure. There's so many wires in here that even though you think you'll remember what it is, you're probably not going to. So, and then yeah, there's a bunch more stuff over here. Water pump, AC outlets for our bed. This is our solar cables, max air fan. So that's pretty much all of our main circuit wiring. We'll still have to do a run for like our DC charger, but I think...
And our heater.
And our heater. Yeah, our air heater, space heater. And then, yeah, we'll also add a bunch of protective stuff. So here's like some edge guard, just made out of rubber. We'll also be using some grommets here and there like we use for these. And then also some 1-inch conduit just to protect it from any other rubbing in this high vibration environment.
Nice.
Toodaloo!
Toodaloo!
I want to figure out what I'm doing with this big cable loom. So right now it's running from the front to the back, and this is what controls like your backup camera, your reverse lights, your tail lights, whatever. So what I'm doing now is just trying to get a little bit of slack in here so that I can hopefully just tuck this upwards more, or at least get more slack for the front side to tuck up. So down here, it seems like to get a little more slack, I've had to take off these 2 pins, or these clips. They were just in these little holes here. Pulled those out. There's one more in here that kind of connects at this like vertice where all the looms join up with the main one. And then there's also a clip back here by this corner. So removing those, I think I should have just enough slack so that I can tuck this up along the ceiling. And then we'll go from there. Okay, so I missed a few pins from my last statement, but yeah, there's an additional 2, or no, an additional 3 in this back corner pocket. So you have 1, 2, 3, 4, 5, and then I believe it's 6 right here, and that gives you lots of slack to manipulate this wire loom. So for the zip ties, I'm just gonna try to remove one on camera for you, but we figured we'd just remove them instead of cut them in case we ever need them again, and then that way we don't have to buy one that will only ever get used for this project. So I got my knife in where the tongue is. I just kind of wedged it in between the tongue of the zip tie and the grooves of the side of it, or of the tongue and the grooves. And then once that's in there, you can kind of just wiggle it out. There you go. So now you could technically reuse this if you wanted to. And then for the taped ones, this is pretty self-explanatory, but I'll just record this just in case. There's just a bunch of tape that surrounds the tabs that you can just unravel. And ours are pretty hard to see just from all of the wear and tear from the van over however many years. This is a 2020, so it could be like 4 years of just rubbing and whatnot, so the edges aren't easy to see. There we go. Got it out. And since this is all sticky, I'm just gonna ravel it back. Ta-da! I got the wire loom figured out. So with our blob, just notched out a little hole right here. That's gonna run kind of following this rounded edge down the length. And then I'll have to figure out what I'm doing over there. I ran some little conduits or wire looms through our high traffic wire areas. So I got one on the passenger side, one on the driver's side. And these things are pretty sweet because you can either, you know, if it's empty, it's probably easier just to push a wire through or a cable through. But they're also split, so you could just like shove it in there from the side. And then I'm also gonna throw in some of these protective rubber edge pieces here, this black strip anywhere where our wires don't run parallel with the sheet metal. So pretty much like right here would be a good one. I kind of just threw this one on here. It's probably a little redundant with the protective loom here, but there's some parts in various places where we'll throw that on. It works pretty good. Might also need to glue it down still, so looking good. So I went ahead and taped up all of our empty connectors. They're not really connected to anything, but I want to deal with this cable loom. So right over here, there's a nice like little rounded cut which it'll tuck into. But if we move along this side, it's kind of like this awkward junction, right? And it's kind of like in the middle of everything. And even if I tried to pull this tight, we still don't have enough slack to like move this into the corner and get rid of all of these excess cable. So in order to tuck this nicely into the corner, we're gonna extend these grounding points about a foot, because that's the only place where it's catching. So there's not enough slack in that branch there. So if we extend that by like a foot, then we'll be able to tuck this up. This will be probably like a right angle here, and then any of this excess we could tuck into this cavity. So let's do it. I just finished splicing in that little extension. You can see the copper connector there. I joined all three of them. And now, for this guy, I have way more slack. So I can bring it all the way to the top here now. And then I can eventually tuck this into the cavity.
It kind of protrudes past where the wood is, and we're going to want to put our plywood walls in here. So we're going to unravel this bundle of wires and try to flatten them a little bit and then rebundle them so it sits kind of behind where our plywood walls will go on. So that's my job today, unraveling all of this and rebundling it in a flatter package. Okay. Ooh, that's sticky. We're about halfway through unbundling. Hello.
So we're about to test fit our piece of plywood.
Don't take over my video.
I'm jacking the thing.
We're gonna rebundle it with this electrician's bundling tape that we got at Home Depot. So it's a little bit different than what we're taking off here. We're trying to find a match to this. It's more of a felt material. I don't know what material this is. It's not felt though. And it has ridges. Do you know what this is?
Probably some sort of vinyl kind of thing.
Some sort of vinyl kind of thing.
Yeah. You know what else is bundled?
Oh, baby.
This little bundle.
Don't unbundle her. She's a cozy bundle.
All right, folks. So our next step in pre-wiring is to get our B2B pre-wired. So that's basically going to be a run from underneath the driver's seat where the vehicle battery is and like all of the bus bar connections. We'll run a red and black 4-gauge wire along this guy, and then it'll come up through our galley cabinetry and ultimately run to our battery bank, which is back here. As you can see, I've already kind of done a little bit of disassembly. It's very simple so far. Basically, there was these two kind of fasteners there with the yellow lines through them that held this framing piece in. You lift that up and out, then you can remove all of these plastic covers, and now you have access to the battery by, you could slide the chair back and forth. So as I was under here, I cracked open the little fuse panel here. This is where your CCP1 and if you have it CCP2 modules will be. We only have a CCP1 in here, which is too bad because I always assumed we would have had a CCP2, but we don't. So, and the actual terminals or the studs that you would connect to are on the door side of the driver's side chair. So yeah, there's usually a CCP2 stud there that's usually larger, rated for 175 amps, but we only have a 60 amp CCP1 in here. So since our B2B is 60 amps, we're gonna have to figure out our own way to kind of shut it down and off, or shut it on and off, which will involve basically just connecting our leads to the bus bars here. And then we'll have to tap into something known as a C33E connector, which is kind of like at the front right of the driver passive pedestal. I don't know if you can see it in here. We'll get a close-up of it later when I check the chair off. But that's what gives you all of your various signals. So I can't remember all that's on there. There's some that are, like there's definitely an engine run, which is switched ground when you turn on the engine. And then there's some other ones, I can't remember, but yeah, different years have different number of pins. So I think in 2019 they switched from like a 8-pin to a 10-pin, which is what we have, the 10-pin. And then previous to that, I think there was a chance of you having a 6-pin too. So consult the BEM and see what pins you have, and then what signals you have. But basically we're going to be using those signals that come out of that connector and run it to the ignition signal on our B2B, which will sense when our vehicle's on or off and charge accordingly. All right, we are in the shop now, and I just wanted to cover this connector kit that we got. So this is what will plug into that C33E connection point underneath the driver's seat. And this is, again, that connector is what gets you the various signals, like when your vehicle's on, or there's also load shedding signals. So ours came unterminated, so you had to kind of crimp these Molex connectors onto a piece of wire. This is what we ordered. We'll leave a link in the description. It seems like it fits fine. It's all good. And I guess the part number is WPT1037. So since this came unterminated, we had to terminate them ourselves. So I basically got, I think this is 16 gauge wire. You probably don't need to have this thick of wire, but we just kind of had it laying around. And I stripped the end of it and got one of these Molex connectors. They actually sell special tools to crimp these on. I didn't really feel like buying one, so I just ended up using some pliers to crimp the stuff. So looking closely at one of these, here's the connection side. These longer prongs go around the insulation of your wire, and then this middle prongs here, they go around the actual conductor. So once you've kind of crimped them on, I basically just folded them over and squished down on it with some pliers. You could just shove them in to your actual connector and it'll kind of lock in place. And you can also remove them too. It's a little bit of a pain. I haven't had to do it yet, but from what I've read, like if you get like the ink of a ballpoint pen, you can kind of try to push it through from this side, this white side. So as I mentioned earlier, our B2B charger is 60 amps, and it also has a ignition sense line. So it knows when, when it receives 12 volts, it knows to charge the batteries, and if it doesn't, then it won't charge the batteries. And it's basically just this single conductor at 12 volts that needs to reach the B2B when you want the device to start working. So that's a little context before I get into this connector here, this C33E. So from this whole connector, since we only need positive out, but I want it to only run when the engine's running, my plan here is to use just these two pins, which is pin 2, this black, which is a switched ground which is switched on or closed when the engine's on. And then this red line, which is our power line, it relates to the ignition position. So I think the two positions where this 12-volt line is active is on run or accessory. So this is also switched. It doesn't necessarily need to be because we're already kind of switching it based on the ground, but I figured, might as well just get both the ground and the positive from this signal here. So I guess maybe there's like double protection or something. But yeah, so since we only want it to run when the engine's on, we have to use a relay to basically take our switched ground as the signal and push out 12 volts when we want power to our B2B, or when we want our B2B to run. So in this case, it's the perfect opportunity to use a relay. And it doesn't need to be anything too crazy. I think out of the positive 12 volts, I think the max for this red line, which again is the ignition line, is 10 amps. We're realistically not ever going to use that much out of it, so it's fine. But I did pick up like a set of these relays. Basically, we're going to wire this up so that when the engine's on, send 12 volts from this line. So this provides the power, this provides the signal. All right, I am by no means an expert in electronics, but from my understanding, all a relay really is just an electronic switch. So the way it works is there's a coil in here that basically opens and closes the circuit depending on if it has power or not. Now when the circuit's closed, you could also have an alternative power. In this case, you could go up to 40 amps and send that through. So this way, if you did have a switch, you could use like a thin wire that is basically just a signal to turn on and off the relay to send the actual power that you want through to your device. For our purposes, since we don't need high power or anything, we're basically just going to use the same power going in and out, which is again coming from the C33E connector harness. Oh, and one thing I also forgot to mention, but yeah, I did mention it earlier that you can, just use a smaller wire as your switch that turns on the relay to ultimately push power through it to your device. I considered that too, but I think I'm just going to skip on that. It wouldn't be hard to add later on, but I did pick up this 90 amp DC circuit breaker that I can technically use as a switch. So if I, even if the engine's running and I don't want the B2B running, I could just cut all power to it. This is where all my 4-gauge wires would connect to. It's definitely not ideal to do that with a circuit breaker, but since we shouldn't be, switching it on and off manually very often, I don't think we should have any issues. All right, so we've got it all together now. Just for now, I used some wire nuts just to make sure that everything works as expected before I put something more permanent on them. Wire nuts are generally not good for like automotive purposes. They will work, but they can spin out, especially for automotive stuff, since we are using stranded wire, which is another thing that wire nuts aren't the best for. But here's an overview of the concept of what's happening. So our C33E connector, this will plug in under the driver's seat. It has our ground, which is a switched ground and is active when the engine is running. That runs into the ground of our relay, which is pin 85. Then back to the connector, you have this red wire, which is our plus 12 volts coming out of pin 6, which is active when the key is in the ignition and the ignition is on accessory mode or run mode. So from there, it goes into our relay. Here we have pin 30, which I believe is the blue. which is ultimately the power that gets passed through the device. And this is also connecting to pin 86, this white one, which provides power to the coil. So since we're sending the same power to the coil that is going to the B2B input or ignition signal, we just spliced them together. Then this red one we can ignore. Our relay came with a normally closed position, so when the relay's not running, this will be active. But since that doesn't really have a purpose for us, we're just gonna ignore it. I'll probably just tape it off or something. And then finally, this yellow, which is pin 87, is the one that's switched based on the coil. And that ultimately goes to the B2B through our ignition signal line that came with the device itself. So we're gonna take this into the vehicle, plug it in, and then we'll get our multimeter out, just test that all the signals are expected, and then we should just be able to pre-wire this in. Hopefully this is long enough. All right, so we're in the van now. I was really hoping I can reach the connector, but I can't, so that means the chair is gonna come off. So we'll take that off camera. All right, y'all, I got the chair off. Same process as the swivel seat side passenger seat. So the 4 fasteners or bolts on each corner, 1, 2, 3, 4, plus the little connector that goes under the seat. So I think these are number 10 sockets, and then that one you probably want like a number 7 socket on the end of like an actual screwdriver style thing. So the connector that we're talking about is right there. So that one in the back, that is our C33E connector. So check your BEM to see the pinout for what signals come out of your connector. But for ours, 6 and 2. So what we're gonna do now is plug in our connector. And then hopefully I could turn on the engine without that being plugged in. I don't know if it's gonna throw a fit if I try to start the engine with no chair in here. So we'll see. All right, this is gonna be a little tricky to do without having more than 2 hands, but I got my multimeter out. The keys are out of the ignition, and I've connected my multimeter connections. My red's going to the little connector that goes to our B2B, and then our black connector is just grounded in one of the holes on the pedestal for the seat. So to confirm if this works, basically we should only be seeing some sort of voltage around 12 volts, maybe around 14, when the engine is on. So I'm going to set you down there, and then I'm just going to put my keys in to the ignition and let it sit at the various ignition positions, and then finally I'll turn on the car. So again, we should only see 12 to 14 volts or so when the vehicle is running. So right now, keys are just in the ignition. I turned it on to accessory. Still nothing. And now we're on run, but the engine's off. And now I'm going to turn it to start it. Now the engine's on, and you can see that we have voltage. So it looks like it's actually climbing 12 to I guess 14, 15 volts. So perfect. It looks like our wiring's good. And I think that this jumps up voltage. I forget what it's called, but SRC. It's kind of like a smart alternator thing where it'll increase and decrease the voltage based on the needs of the alternator and the battery itself. So it looks like our wiring is good. So now we'll repeat the tests by turning off the vehicle. So we're on run now, and I just switched it to accessory. You could hear that the engine's no longer running, and now there's no power coming out of here. And finally I removed the keys, and we are good. So I think we're good with that now. I'm just gonna let this go. But yeah, so our next steps, which unfortunately is gonna be a little bit more of a pain, is I'll have to remove this box, this plastic box holding the battery, which means I'll need to take off the terminals for the batteries, remove the box, and then get into this fuse panel here, which is where your customer connection points are. And that's ultimately where I'm going to tap into. So since we don't have a CCP2, there is kind of just an open stud here, which I'm planning to route our 4 gauge to that stud, to our circuit breaker, probably mounted on the pedestal here, back out to the 4 gauge, and run it back. So we're doing good. I'm happy that all worked out. Again, we'll leave the pinout and the various connections for the relay in the description. It's not that complicated to figure out. Hopefully it goes as smoothly as it did for me. Sounds like 4th of July out there. There's a huge thunderstorm. But yeah, there's something kind of sketchy feeling about playing with electrical stuff while in a thunderstorm. But yeah, so I've thought about this whole process, and I think I could do what I need to do under the chair without having to take all this stuff out. So I'm being very lazy, but that's okay. But yeah, so in here you have this kind of plate here, this face plate, which is where all of your fuses are. So generally there's a bunch of, like, see all these little leads there, or studs? Those are all fuses. They might lead to your CCPs, they might be fuses for other things, but I think generally they're all 60 amp. But to the left of that, you have this stud. So this stud is where CCP2 usually is. And this is like part of the main bus bar. All of this silver stuff connects directly to the battery. But CCP2 is usually connected to this stud. It fills out the space to the left with maybe like a relay, and then ultimately it ends up with another stud to the left of the chair where you can connect to it. So for our purposes, I think I don't need to take out this whole assembly, because I could probably push this far enough to the point where I can get a little socket wrench in here, unscrew this stud or bolt, and then attach my wiring to there. And yeah, I think that should all work. So the only things I really need to do out here are make sure I have a connection from here outside over here, so that I can later run my wire to my B2B. Yeah, I figured we might as well get some of these dependencies done while I already have the chair off, and hopefully once I get this mounted and connected, then I shouldn't have any business under here for the rest of the project. So with that being said, that means that this circuit breaker, at least for the battery side, will be live. That's okay. I will either leave this just kind of open or off in the meantime, or even just leave this disconnected too. But that way we don't have power running through our 4 gauge wire and kind of just floating out in the open. So that's our plan. Should be good. Oh, and just for reference, yeah, so I did have all of this like various lug size kit. But yeah, this lug is, I believe, a 5/16. This is what will connect to CCP2 stud. It'll go to my 4 gauge wire, to this other lug here, which I believe is for 4 gauge, but this size is, let's see, this size is a 1/4 inch stud, so a little bit smaller. But yeah, that's just what this 90 amp circuit breaker does. So would highly recommend this, just so you could try to fit everything without having to deal with ordering a bunch more or less or whatever. All right, I got my terminations on my piece of wire that's gonna run from my vehicle bus bar to my circuit breaker. So I also brought out the CCP bracket and cover. And my plan is, so instead of running the wires out of the normal CCP holes, I'm going to modify the bracket a little bit so that the wires will go towards the front of the vehicle instead of out the back. And that's where I'll mount my circuit breaker, more like this. So I basically need to reproduce these cutouts, and cut out this on this side, and we should be good to go. So I did try to reverse this, but it's not symmetrical. So it's not as simple as just saying, hey, this is originally like this, why don't you just put it like that? You can't do that. And then luckily the cover cap is reversible, so I can either put it on, you know, the normal way, or just reverse it and go this way, which is how it'll ultimately be. So now my wires would come out of here once I cut the holes. So I got the Dremel out. I'm probably just gonna cut off little tabs and then just round it over with one of the sanding bits, and then we'll go from there. And this is how it came out. So I basically cut off this little loop from here to here, and then I also cut out these two square holes here and here. So you'll notice that this side's a little deeper, and that's because when we put on this cap in reverse, it kind of like clips this edge. So instead of having to modify the cover also, I just took this one a little deeper so that if I ever wanted to revert it, I would just have to buy one piece instead of both, but they probably both come together, I don't know. So we're looking good, and this is by no means perfect, but if you don't look at it, it'll look perfect. So now we'll take this back to the car. I don't think I'm going to mount this completely yet, but for the time being, I'll get this mounted on. You just snap it back in, throw the wire through, and then bolt this down. And this will be a little floppy for now, but probably tomorrow I'll finish it up. Screw this into the driver's pedestal. So, nice. So I think one of my best decisions today was removing the driver's seat and placing it facing where I want to be working, which is obviously underneath the driver's seat. So this whole time I've been able just to be seated while doing all my work. It's been very ergonomic and comfy, and honestly I want to take a nap now. But in any case, it's getting a little dark out. I was working on feeding the wires through the pedestal, but it's kind of hard to see, and I didn't really feel like dealing with a headlamp. So I'm going to stop there, but I will show you what I've accomplished so far. So flipping you around, we did get the C33E connection going. That actually worked pretty well. I removed it. It's in the workspace right now because I'm going to make those permanent connections with some solder. And then down here by the CCP area, I got my battery cable connected to that CCP2 stud, or where the CCP2 stud would be. And then it's going to my circuit breaker, and then now my lead that will go to the B2B is connected. So I did wedge something in between the reset switch of the circuit breaker as well as taped over it so that we don't accidentally turn it on. I would rather not have a piece of energized wire in our workspace while we're screwing holes and screwing screws and drilling holes, and so I've also just taped the end of this in case it, I don't know, comes into contact, and also if that switch magically came on. So in any case, we're looking pretty good. My next steps are to get that mounted and figure out how to run this down underneath the pedestal, underneath this factory flooring, and around town. So that'll be a problem for tomorrow. So we'll give you a little sunset. We'll give you a little sunset shot. We'll give you a little sunset shot right now, and then we'll jump to the next day where hopefully Liana will be helping us out. Sunset shot, sunset shot. Couldn't say it 5 times fast. Alright y'all, it's the next day. It's light out, so now we can see things better. But I still haven't passed my sensor line to my B2B yet, but that's just pre-wiring. I did attach the relay and my C33E connector. I just use a zip tie to hold it in place here. But I wanted to point out the way that I routed these cables just because it might be interesting to you or useful to you. So yeah, I got the ground wire here, and then my positive comes in back through the fuse box. So you could see this is actually my red, and here's my black. And the way that I found was possible to exit the pedestal was there was like a slight gap kind of in between the back corner of the box that holds the battery and the framing of the pedestal. So there was a little gap there. You can almost kind of see my fingers, maybe not. But I was able to sneak the wires through there. I added a little bit of edge guard, or the protecting rubber stuff. And then I was able to exit. Then I kind of routed them back towards the e-brake. So you could see the wires sticking out there. I wrapped them in like automotive tape, just so that like the red and the blacks are a little more color matched to the factory matte and less visible. And then they kind of route underneath some of the framing pieces here. And since there wasn't really a way to exit the pedestal, and also, or I guess there wasn't a way to be underneath the floor mat, I had to cut a little slit right here. And so that allows me to go from above the floor mat to underneath it. And now here you can see my two wires here. So now I can just cleanly go all the way around out back. And yeah. So now I gotta put the seat back. It's gonna be a sad moment because it has been nice sitting on this chair while doing all my work. But I think that's the end of pre-wiring. So hopefully some of this information was useful to you. If it was, leave a like, maybe subscribe. And if you have any, I don't know, tips for us as we proceed through here, let us know in the comments. Bye bye. Say bye, Bailey. Say bye, Bailey. Aww.